Hello and welcome to this short presentation about considerations for your HVAC system, both during and post the current COVID-19 pandemic. We'll be taking you through 8 recommendations by industry experts to help keep your indoor air clean in your food production facility at this current time. It has been widely reported that viruses, such as COVID-19, are primarily transmitted from symptomatic people to others who are in close contact through respiratory droplets and also by direct contact with infected individuals. Scientific sources tell us that a single sneeze can release up to 40,000 virus-laden particles into the air, and that these droplets can travel up to 8 meters. For a cough, that is 3,000 droplets travelling as far as 6 meters, and even talking produces infectious droplets. Researchers estimate, for example, that a single minute of loud speaking could generate at least 1,000 virus-containing droplets. Viruses can also be transmitted by contact with contaminated surfaces and objects. A recent study has found that the coronavirus itself can remain viable on copper for up to 4 hours, on cardboard for up to 24 hours, and on plastic and stainless steel for up to 72 hours. The same study found that coronavirus will remain in the air for up to 3 hours, and indeed the World Health Organization tells us that particles of less than 5 microns will remain in the air for many minutes or even hours. With this being the case, it stands to reason that preventing airborne transmission will not only help reduce transmission through the air, but also contact transmission due to the buildup of virus particles on surfaces. With an increasing number of people inhabiting communal buildings again, it is vital to put in place control measures to prevent the spread of any disease such as COVID-19. The HVAC engineering controls I'm going to talk about in this webinar relate to food production sites and to other buildings with HVAC systems. And of course, all controls should be used in conjunction with other measures such as social distancing, PPE and hand hygiene. The first measure is to avoid recirculating air. The reason for this is that virus particles can re-enter a building through the recirculated air system. Most air handling units have a duct between the exhaust air and the fresh air intake that allows some of the exhaust air to be recirculated back into the system. The Chartered Institution of Building Services Engineers, CIBSA, recommends that any ventilation or air conditioning system that normally runs with a recirculation mode should now be set up to run on full outside air where this is possible. This advice is echoed by other industry bodies. Using fresh air rather than recirculated air will help prevent any pockets of stagnant air. Preventing recirculation and transfer of air from one room or production area to another is recommended unless recirculation is the only way of providing adequate ventilation to all occupied areas. In order to run on full outside air effectively, according to CIBSA, you need to calculate the appropriate volume of outside air required and reconfigure your air handling system accordingly to provide it. The next recommendation is to conduct a review of your ventilation strategy. CIBSA specifies that it is important to conduct a review of all shared spaces. This should start with a risk assessment of your building or production area. And HVDS can provide a risk assessment template based on the BRCGS Food Safety Issue 8 if you would find that useful. The Building Engineering Services Association, BESA, highlights that it is important to consider any measures in this review that might have been implemented over the last few weeks or months in response to the pandemic, which could be restricting the airflow. These might include, for example, the introduction of partitions for social distancing reasons. The Federation of European Heating, Ventilation and Air Conditioning Associations, REVA, recommends increasing the air supply and exhaust ventilation operation times in buildings with mechanical ventilation systems. However, HVAC systems are complex and are usually tailored to the specific requirements of individual buildings and production areas. For this reason, extending the operating times is not a matter of simply flicking a switch. Apart from ventilation rate, the other requirements that need to be considered include temperature control, relative humidity, airflow direction, and air distribution. Systems should be customised as needed by HVAC engineers to reduce the risks of airborne transmission. Industry experts are predicting a greater focus on ventilation hygiene in the wake of COVID-19. The Building Engineering Services Association, BESA, has said that a more frequent and rigorous cleaning schedule is recommended. They say that it is more important than ever for systems operating on full fresh air that the ductwork is properly clean, and point out that if a facility needs to move to a higher risk category as a result of changes brought about by the pandemic, it will be subject to more frequent ventilation cleaning. Cutting back on cleaning could increase the risk of fire associated with the buildup of dust, debris, and particularly grease in ductwork and fryer extract flues. The BESA indicates that grease buildup should be kept below 200 microns. We would like to point out that cleaning should be carried out in accordance with the BRCGS Food Safety Issue 8, Section 6, which gives guidance on best engineering practice with regard to the ongoing maintenance, condition, and hygiene monitoring of ventilation equipment. All parts of the air handling system should be inspected, including but not limited to cooling coils, fans, motors, and the sides, walls and floor of the air handling unit itself. Cleaning should also be carried out to TR19 and the new TR19 grease standards. TR19 establishes safe levels of ventilation hygiene for all types of building and mirrors the international standard BSEN 15780. Regular filter changes will help to combat microbial growth on filters, and of course, as indicated by REVA, clogged air filters reduce supply airflow, which has a negative effect on indoor contaminations. So maintaining a regular filter change schedule and increasing frequency according to the findings of your ventilation strategy review is important. HVDS would recommend changing filters to a set schedule rather than to pressure drop readings. This is a more preventative course of action and eliminates the risk of overlooking this crucial element of maintaining an air handling system. Filter frames should also be checked for an airtight seal. Particles can bypass the seal if it has been fitted incorrectly or if the silicone around the filter frame has perished over time. CIBSA advises that air filters should be changed with systems turned off where possible and that old dirty filters should be disposed of responsibly. A lot has been said over the last 3 months or so about HEPA filters. High efficiency particulate air filters are able to trap 99.97% of airborne particles of 0.3 microns in diameter or larger. For this reason, they are used as a final stage of filtration in buildings that require a higher level of contamination control, such as in hospitals, research laboratories, and certain food production facilities. If any of your production areas have moved to a higher risk category as a result of the pandemic, they may require HEPA filtration. It is worth mentioning that not all air handling unit fans are capable of creating the extra airflow needed to push air through HEPA filters, although secondary filters can be increased to an EPM1 80% filter according to ISO 16890, which is the old F9 grade. Newer and/or larger HVAC systems may have heat exchangers. According to REVA, these may carry over virus-laden particles from the exhaust air side to the supply air side via leaks. Under certain conditions, these virus particles in extract air could re-enter the building. Poorly designed or maintained rotors may be prone to leakage. However, REVA says that virus particle transmission via heat recovery devices is not an issue when an HVAC system is equipped with a twin coil unit or another heat recovery device that guarantees 100% air separation between return and supply side. Inspect your system for air leakage and, if it is found, CIBSA recommends bypassing the thermal wheel. If the wheel can't be bypassed, the rotor should be turned off and the ventilation rates increased. In addition, heat recovery equipment should be regularly inspected and the pressure difference measured. And now the last recommendation, which is to test local exhaust ventilation equipment as normal. LEV testing remains a statutory requirement, and the COSH regulations 2002 still apply during the COVID-19 pandemic. If your business remains open and your process and machinery are running, the HSE guidelines state that you must still manage the risk to protect your employees. The British Occupational Hygiene Society states that a thorough examination and test of each LEV system is required at a minimum frequency of every 14 months in order to comply with the law. If your process and machinery are not currently operating, according to HSE guidelines, an LEV system should be subject to a thorough examination and test prior to restarting. The position with regard to LEV at this time is constantly under review. Thank you for listening. We hope you found that useful, and if there's anything we can help you with, please don't hesitate to get in touch.